This conference will now be recorded.
Hi, this video I'm going to show you how to implement RiverFlow2D model for the first time from scratch using the QGIS RiverFlow2D plugin. The first thing when you install the software, you need to make sure that as soon as you open QGIS, you should make sure you can see the plugin icons are these I'm showing here. And these are icons that are used to access different features of the model. So if you don't see that, when you open QGIS, you can come here to the plugins menu and click Manage and Install Plugins. And in here, in the installed plugins, you should click on the RiverFlow2D, RiverFlow plugin, that is this one here. So that will ensure that the plugin is correctly recognized by QGIS. Okay, so the first thing you do when you want to enter the data for a new RiverFlow2D model is to create the main environment. And this is done by this first icon here that's is called the new RiverFlow2D project. And when you click that, you get this dialog that allows you to select which layers you want to have. In this particular one, I will select none because I don't want any of these layers now. And one thing that is very important is to select the proper projection. And in this case, I'm going to be following the Create Your First RiverFlow2D project plugin, the first RiverFlow2D project with QGIS plugin, and I will be using the whole QGIS data that is here. And you have that data when the model installs in your documents folder, RiverFlow2D underbar QGIS example project. So in this whole underbar QGIS, we have the data that I'm going to be using. And we have a raster, we have an aerial image, and we have an inflow Hydra graph. And also this little file here that just indicates which the projection, which is the projection we're going to be using. So we're going to be using the EPSG 102748 in feet. So that's one projection that corresponds to the state of Washington, where this river is located. So I'm going to be clicking here. This is critical for the QGIS environment because QGIS always needs a projection to work in. So click here and select, you can filter here, for instance, if you enter Washington. So in Washington State, so we have this NAD 1983 State Plane, Washington North. So this is the one we're going to be using. So select that. Then for the project directory, you click on the button and then select the project folder. And that project folder is the one that I show you, is RiverFlow2D QGIS example projects or underbar QGIS. So this is the folder we'll be using for the files. So all the files that will be created and also the model run will be this particular folder. Well, when you click OK, then the plugin will create some standard layers for you. The main outline is the one that we'll be using for creating the external extent of the model. we'll be using this one here. The boundary conditions is where we are going to be entering boundary conditions, inflow and outflow, mine sand, the roughness parameters, and so forth. So I'll be going step by step. But first, we need to import the data. And the data we'll be using is mainly the bed elevations, and the bed elevations for this particular river are in a raster, and we use this add raster layer to import that particular file. That particular file is this one here, dem hoh underbar feet. It's in the same projection system, and once you create that or enter that file, it will show the raster that was created. I always like to change this because it shows me better the properties. You right click this DM and click on the properties, and I will use in the style, instead of single band gray, which is the default, I'll use hillshade and click apply. Okay, it gives me a better depiction of the terrain here. Now you have to bear in mind that the rasters may include triangles that may not be totally correct, and you can see here that this area may not be in the original data set. I'll be moving down the DEM so that it will not affect other things I'm including now. So I will now enter, I can enter also import an aerial image. It's here the whole TIFF. It's an image in the same projection system, and it's one that I will be putting on the bottom also, so not to interfere with the rest of the layers. So if you see here, this is a river. There is a river band here, and the flow comes from upstream down to this downstream to the south. Okay. So next step would be to enter the polygon defining the domain outlines or the extent of the domain. We'll be using entering that in this domain outline layer. So we click this the pencil and then this add feature. Then we enter, by entering clicks, we create the external polygon that will represent the total extent of the modeling area I want to model today. So when you're done, you right click. Then you get this dialog here that you need to enter the cell size. This cell size will be used by the mesh generation program to create the mesh with triangles. So this is an average of the triangles. I would be using, say, 50. So this is, let's use 50. Okay, there would be 50 feet because this is this projection is in feet in English units, so I'm using all the units will be consistent with that projection. And once you finish, then you need to click here on the pencil again and click save to make sure that the changes you have made or the data you have entered is correctly entered in the QGIS environment. So the next step would be to enter the boundary conditions. So the boundary conditions are entered here in the boundary conditions layer. Again, I will use the pencil here, click on the polygon, and I will enter a polygon that covers the entrance, that covers the inflow boundary. Then right click, and in here you enter, this will be an inflow boundary, and the type of boundary that I will use will be discharge versus time. And I will import a boundary conditions file that is created here in the folder is qin.dat. That file, if you click here, you will see that has 3 entries for 0 hours, 1000 CFS of cubic feet per second, for 0.5 hours is 67,000 CFS, and 100 hours, 67,000 CFS. So I click OK, and then I click Save, and I have this inflow boundary already. So I need an outflow boundary. And for the outflow boundary, I need to make sure this pencil again, the edit, it's in edit mode, the boundary condition layer. I enter the add feature, and then I create a polygon here that covers the external or the downstream boundary. So we right click, and in this case, I will use an outflow condition that will be uniform flow. And for uniform flow, you need to enter this slope, that is the slope that the model will use to generate a rating table based on Manning's equation. And I will use 0.03, which is a reasonable slope for this particular location. Okay, so I save. So now that we have that, we need to enter the Mannings polygon. So the Mannings polygon indicates the roughness. So again, I click on the Mannings N layer, click here, click on the add feature polygon, and I will create a polygon that covers, make sure it covers the whole area. I will use here a single Mannings just for the purpose of this initial project. You can enter as many as you need, and also you can enter a shapefile with pre-assigned Mannings of different polygons. So I will use a single Mannings 0.035 for the whole area. And remember also that you need to click here on the toggle editing to make sure that the changes have been saved. Okay, so that will be all in theory, I need to make a first run. Let me first save the project. I will save it, I will call it O1. And then this is all the spatial data we need to run the model. So we need now to generate the flexible mesh. So for the flexible mesh, we click here, the second icon that indicates generate tri-mesh. And that will generate a triangular element mesh for the whole area. You can also refine the mesh, but for this first example, I will leave it as more or less uniform. So the final step before running the model is to export the data to the RiverFlow2D native format. We use the third icon here. So we click here, and then we have to make sure that the DM that we're using is the correct one. It's this one, DM whole in feet. So this is important because if you have many rasters, the default may not be, it will be the first one and may not be the correct one. And then I will use here for the project, I will call it here, it's a first one. Okay, so this will be my first project, and I click OK. And then once all the files are exported, then you will see the what is called the Hydra data input program, which is the environment on which you enter the data that is not spatial. For instance, you can enter here the simulation time, the output interval, if you're using modules for sediment transport or other feature that the model is able to use. Then I will leave the defaults for now, so I will just run the model from here. Since I have not changed anything, I will not save things here. So once the model starts running, it will bring up this this screen where you will see different things. So you will see the graphics of the water depth. Here you will see the discharge, the inflow and outflow. You will see the volume conservation error for each time step, and some other information that the model provides while the model is running. So when the model finalizes running, see that we have 2 hours here, the simulation time stated. So you will see here in this info the total time that was used for this particular run. So when you're done, you close the window. And then there is still some post-processing things that are done in this part. But you can go back to the QGIS environment now that the model has finalized the run, just to look at the results. There are many ways to look at the results in the model. So let me first show you, for instance, if you want to look at the results versus time, you can use this icon here. And then I will select the output files. And in this list here, what I will want to do instead of plotting, you have here the output times. I will use for the last time, for instance, I will want to see the water surface elevation and the depth, for instance, and velocity magnitude. And I will want the results as a raster. So what the program does, let me turn off the tri-mesh, and let me turn off the DM. It will plot, for instance, this will be the velocity magnitudes. So you'll see a raster of the velocity magnitudes. You have a layer for the water surface elevations. And then you have also a layer for the depth of flow. Each of these plots have in the background and in the project folder, you will find the files that represent these rasters. Or if you use a vector plot that you can do also for the triangle of cells, you get shapefiles. So this is one of the plots that you can do. One plot that is very interesting and I think is very useful in the model, I think is the cross-section tool. And in the cross-section tool, if you click the cross-section tool, this dialog will appear in the bottom, and you can create a cross-section or a profile and look at the results here of that, the velocities and the water surface elevation. So if you, for instance, click here and click here, then you see that cross-section on this red line. And there are interesting, nice features. First, you can animate the cross-section, clicking here. But also, you see that as you move the cursor, let me stop it here. As you move the cursor, you will see a red point here that indicates this particular point on the cross-section, at which point on the plane that corresponds. So it's pretty useful. And also you have this these graded blue areas here in the cross-section that indicates the velocity. You get also the height graph on that cross-section. You get a numeric table of the actual data that was generated over the model results for that particular cross-section. You can also enter a profile, and that profile, it's entered as a polyline, for instance. So if you create a profile here, that profile will be shown here, and you can also animate the profile, and we'll tell you how that profile evolves over time. So These are only two of the features that are used for the model plots. There are many others, but I want to just stick to a particular time that I have for this initial video for just to help you get started with the RiverFlow2D model. So I hope you find this video useful for your purposes. If you have any questions, just don't hesitate to email us at support@hydronia.com. Thank you very much.
This conference will now be recorded.